Hello everyone, we are Group 6 and today we are going to talk about our business proposal NFC in Australia public transportation. This is our content, and first we will talk about background, problem, interview, and solution. And also we will talk about SWOT, our ERD, DFD, and at the end we will talk about our conclusion. Next, we are going to talk about our target market and data collection plan. Section 1 is research focus and objectives. Our topic is NFC technology adoption in Australia. Our key investigation is analyzing low countless transaction rates in rural areas due to limited mobile coverage and infrastructure. And secondary issue is that examining the efficiency of paper tickets still used in long-distance travel routes. For Section 2 is primary data collection. Methodology is conducting online interviews, and participants is residents and students currently in Australia, including personal network. And our goal is to gathering qualitative insights on our experiences, opinions, and technical challenges. Let's take a closer look at the general market in Australia, analyzed through 5 key dimensions. First is the economic environment. Australia is a highly digitalized society with strong spending power. Since credit cards and mobile wallets are already mainstream, there is a very solid foundation for adopting NFC payments. Second, regarding technology, Australia is actually a leader in tap-to-go system. Major cities rely on NFC cards like Apple and Nike. However, the problem is that many regional areas are still using traditional paper tickets. Third is the social aspect. We see a clear demographic divide here. While the urban youth fully embrace a cashless lifestyle, older generation and rural residents still prefer cash, largely due to habit and limited access. Fourth, on policy, although the Reserve Bank supports digital payments, there is no unified national policy yet. Different states have different systems, which creates gaps in efficiency. Finally, infrastructure. Cities are well equipped, but expanding the technology to rural areas is costly and complex. We are seeing some progress with pilot trials, but it's happening slowly. To sum up, while the urban market is mature, the infrastructure gap in rural areas remains our biggest challenge. So we are going to talk about why some Australia regions still use paper ticket. For conclusion, while Australia lives in countless transportation payments, many regional and long-distance routes still use paper ticket due to fragmented system, high cost, and lower ridership. Pilot programs in Bathurst and Dubbo are expanding countless options, but full adoption will need sustained investment and cross-state coordination.
Then we move on to the interviews. For the interviews, I interviewed university students and working class people. And for question 1, I have how often do you use public transport in Melbourne or Victoria? For question 2, I have do you prefer using a physical MyKey card or your phone or watch to pay for travel? For question 3, do you carry a physical MyKey card or use the mobile MyKey Android, Apple Wallet or Apple Pay for transport or use a bank card to tap? And for question 4, have you experienced problems when using your phone to tap? For example, phone needs to be unlocked and the NFC not working. Next, we move on to the results of the interview. For the results, for question 1, they use the public transport almost every day or every day. And question 2, they say, I prefer to use my phone for the my key just because it's a hassle to keep taking out my physical card from my bag, just to tap it for 1 second and put it back in. And then the phone, it's more convenient for them to use to tap their transportation card. Question 3, they have their physical my key card. And some of them also have both the physical card because they moved to a digital one, especially on the Android phone. But they always have their physical card in their wallet, which they bring everywhere with them. And for question 4, they can't use their phone, but they've never had any problems with the NFC for the Mikey top-ups or the taps. And nope, their phone doesn't need to be unlocked when they try to tap on the machine of the NFC devices.
In our SWOT analysis, we'll be taking a look at NFC's strengths, weaknesses, opportunities, and threats. And starting off with strengths, we are experiencing a rapid adoption of contactless payments across many sectors, NFC being a popular choice. The NFC payment method is also supported by the government, with the government providing incentives and awards for services and firms who adopt it. The expanding applications across smart cities also means that more and more platforms are being provided for NFC to be used in. Collaborations among firms and services like telecoms and bank services allow NFC to plant itself into daily transactions. With its strengths also comes its weaknesses. The modern high tech payment method means that there will be high infrastructure costs when applying it. This makes it rather inaccessible for rural and small businesses, meaning when time comes for them to adopt it, there will be a slow adoption process. Being new also means that there will be low awareness of this payment method, and cross compatibility issues comes with the payment method being so modern and complex. However, in today's society, there are plenty of opportunities for NFC to foster. Many growth is encouraged within cities to become smart, meaning that more modern methods like NFC is encouraged to be implemented among the transaction methods. There is also a rising demand in convenience and digital lifestyle, meaning that more modern solutions are being looked for by more young people. Strong partnerships being fostered in the business world means that NFC will not only be incentivized for other firms and services, but for people as well. However, there are small hurdles that NFC must tackle. Like with many other digital payment methods, there are ongoing data privacy and security concerns for NFC as well. NFC being a more modern implementation means that rural populations will have trouble accessing it, meaning there will be a rural and modern divide. Intense global competition like Apple, Google, Visa, and etc. means that NFC will have competition in the market.
Next, I will be explaining our ERD. Our ERD shows a system for managing passenger tap transactions using the RFID for a public transportation or controlled access system. The primary goal for this diagram is to define the database structure, ensuring we accurately track who taps, what they use, where they tap, and when. This entire model is built around four primary entities: passenger, NFC device, NFC reader, and the central event, tap read. Let's begin by reviewing the key entities and the data points they hold. The passenger entity, which starts from the very left, represents the user and is identified simply by their unique passenger ID. Moving to the items they use, the NFC device represents the physical object used for tapping, such as a transportation card or a mobile phone token. Key attributes for this device includes its unique device ID, a physical identifier called as the device tag, its current status, the issuance date, and the offline balance. Next, the NFC reader represents the physical terminal or gate where the transaction occurs. It is uniquely identified by its serial number and reader ID, tracking its operational status, location, and the direction of travel it serves, such as northbound or southbound. Finally, the tap read entity is the core transactional event, recording the details of the actual tap, including the foreign keys linking it back to the device and reader, the precise tap timestamp, the balance snapshot at the time of the tap, and the final tap result. Now, we define how these entities interact using cardinality to specify the numerical relationship between them. The diagram shows that a passenger can be linked to zero to many NFC devices, meaning a user can have multiple cards or tokens, whereas the NFC device is linked to one and only one passenger at any given time. This specific business rule, which states that a device is uniquely tied back to one user, is managed by the associative entity passenger device. This intermediary table stores the current active link between the passenger ID and the device ID, effectively resolving the relationship for tracking ownership. Furthermore, the cardinality from the passenger device back to the NFC device is also a strict one-to-one. This mandatory constraint guarantees that every single physical device in the system is uniquely accounted for by one and only one relationship record, preventing any ambiguity about its current ownership or status. Lastly, the taproot entity sits at the center, connecting the devices and the readers to record the actual access event. Examining the link from the device to the transaction, we see a one-to-many relationship between NFC device and taproot. This means an NFC device can generate zero to many taproot events over its lifetime. Crucially, every single taproot event must be generated by one and only one NFC device. And similarly, the link between the NFC reader and the tap read is also a one-to-many relationship. An NFC reader can record zero to many tap read events, but every single tap read event must be recorded at one and only one NFC reader. And next up, my partner will be explaining our DFT.
Now, let's take a closer look at how our NFC bus fare payment system works, using our data flow diagrams to highlight its efficiency and reliability. Starting with our context level DFD, the system will be viewed as a single process interacting with two different external entities. First is the passengers, who will provide registration information and select their payment method before boarding. Second is the NFC reader system on the bus, which will communicate with our system in real time to confirm payment during boarding. Even at this high level, it's clear that the system streamlines account management, fare calculation, and real time communication, translating into faster boarding, fewer errors, and improved passenger satisfaction. Moving on to the level 0 DFD, we will break the system into four main processes. First is to manage the account, which will be done by passengers pre-boarding the bus. Passengers will first register and set up their payment method in advance. The system will then securely verify and store the information in the passenger database, which will then send back a confirmation to the passenger. This will ensure that passengers are ready to board the bus without any delays. Second is the record tab. When boarding and disembarking the bus, passengers will tap their NFC-enabled device. The system will then record the device ID, timestamp, and location in the tap records database, ensuring that every transaction is accurately tracked for accountability and analytics. Third is to calculate the fare. Using the tap data and the passenger's account details, including the location and the timestamp, the system will then calculate the fare based on the distance. It will then update the balances and generate a deduction request. Automation like this will help reduce errors and operational costs while help maintaining transparency. Last and final process is to send the signal. Finally, the system will communicate with the NFC reader. If the signal is strong enough, payment goes through, balances are updated, and the reader displays the updated balance. However, if the signal is weak, the transaction will safely fail, prompting the passenger to tap again, ensuring that no revenue loss or confusion will happen. This workflow demonstrates how the system delivers reliable, fast, and secure fare processing while collecting data that can help optimize operations and support future growth, showing investors a ready to scale, high impact solution.
So, in conclusion, even though Australia faces challenges in regional connectivity and fragmentation, the technological foundation and user demand for a fully cashless transport network exist. By addressing the infrastructure cost and standardizing data protocols, as modeled in our DFD, Australia can bridge the gap between urban convenience and rural accessibility, moving towards a seamless nationwide smart transport ecosystem.